हेलो स्टूडेंट, कैसे हो? नाउ HCV and HOTS series will continue. Another interesting question of the electrostatic: the bob of a simple pendulum has a mass 40 gram and having the positive charge of 4 into 10 to the power minus 6 coulomb. It makes 20 oscillation in 45 seconds. A vertical electric field pointing upward of magnitude 2.5 into 10 to the power 4 Newton per coulomb is switched on. How much time will it now take to complete 20 oscillations? So this question, how to solve this question? Simple pendulum like that. Now the point is, first we have to find out what is the time period when the no electric field. Now first stage when electric field is 0. So time period is your 45 by 20 second. That is the time period. So what should be the length that we have to find out? So in this way we know the formula T is equal to 2 pi under root L by G, taking G as a 10 meter per second square. So here it is 45 by 20 is equal to 2 pi under root L by 10. So by calculation, I am doing the calculation with the calculator. L should be, if you are calculating, that is around 1.28 meter. This is the first case. Now, when E is switched on, E is switched on, then what will happen? E is switched on, and that is E is vertical direction. So definitely T will be 2 pi under root L by G minus A. This acceleration due to the electric field intensity, which is upward. So by putting the values, what we will get? T is equal to 2 pi in place of L, that is 1.28, we have find out, 10 minus G, that is how much it is? It's a value Q E by M. How it comes? That electric field, due to the electric field intensity, F is equal to, we know, Q into E. So here it is, acceleration is equal to Q E by M. Force equal to M into A. So A becomes this. So by finding its value, by putting the value of Q, E and M, we can use the calculator, and its value is around 2.5 meter per second square. 2.5 meter per second square. Put its value, so T will be equal to 2 pi under root 1.28 by 10 minus 2.5. After calculating, you will get the value 2.59 second. That is the time period when the switched on electric field is switched on. So this is the time period. For time period is the time taken for one complete oscillation. So time for 20 oscillation will be 20 into 2.59. So that is around 51.9 second around. Means 52 second. That should be your answer. Right? Another question. A block of mass M having a charge Q is placed on a smooth horizontal table and it's connected to a wall through an unstretched spring of spring constant K. A horizontal electric field E parallel to the spring is switched on. Find the amplitude of the resultant simple harmonic motion of the block. Now the diagram is like that. If I am going to move it, it start displacing in this way. When it's switched on, so this is the it executes simple harmonic motion. This block here, the spring is attached and the spring constant is k. When there is a question of the spring and spring constant comes into act, we know the force in this case is minus kx. That we know, where k is the spring constant and x is your displacement, or rather amplitude here. So this is the main equation, and with the help of this equation, force, put the value of the force in case of that electric field which is going to be applied. The charge into electric field intensity is equal to mode we are taking k into x. So x will be QE by k. That is your amplitude. This is the way how we are going to, if say the charge is known and E is known and K is known, you can apply the value, put the value and find out the result. What should be the amplitude? So the sign is negative, we can keep it negative. That will be the amplitude. If the electric field intensity is 10 Newton per Coulomb exists in vertical downward direction, find the increase in the electric potential as one goes up from through a height of 50 centimeter. So how we are going to do it? What should be the way? We know here it is E is given 10 Newton per Coulomb, right? And and the distance is your 50 centimeter means 0.5 meter. So our purpose is to find the potential at that height. We know a very important formula, E is equal to minus dV by dr. If potential and the distance is going to vary, then only it is going to apply. Otherwise, we can write it in this way. V is equal to this. We can write it minus V by R. If variation is negligible or not variation is there, so V is equal to E into R. Mode we are taking. E is your 10 into R or distance S. So distance is how much? 0.5. That is your 5 volt. That is your answer. Right? Other question. If E is equal to E, electric field intensity existed is 20I plus 30J Newton per Coulomb exists in a space. If potential at origin is taken to be 0, find the potential at origin. How we are going to solve it? If this type of question is there, we have to find out what should be the way how we are going to do it. In fact, the question is find the potential at origin, that is at 2 meter 2 to 2-2. That is the distance given. So how we are going to proceed it? Very simple. E is equal to given 20I plus 30J, this much given Newton per Coulomb, right? And we have to find out where at a particular distance R is equal to 2 meter. 2 meter means a 2I plus 2J. So we have to write it. V is equal to the same formula, minus E into R. in the vector product form, E dot R, we can write it here, minus E is 20I plus 30J dot 2I plus 2J. So that will be, if we are going to calculate, minus 2 into 20 plus 2 into 30, that is your minus 100 volt answer.